Hello, algebra students. I wanted to go over numbers 17 and 18 in the Desmos activity because there were a few questions on it. So we are dealing with y equals the square root of x. That is going to be our parent function in chapter 10. So this is from section 10.1. The way that y equals the square root of x looks is this black line right here. Now, when you are on your Desmos activity, it probably looks like this. It's zoomed in, which is fine, except for I don't love the fact that the scale is by 1/2 here. So what I did is I zoomed out and it made my scale by ones. And I think that's a little bit easier to deal with. So as you know, the square root of 1 is 1. And then to land on a nice point where your grid crosses, go to your perfect squares. So the square root of 4 would be 2, and the square root of 9 would be 3, and 16 would be 4. So forth. If you moved your scale that way, you would see your perfect squares landing on where the grid crosses. Okay. So I think there's some strategy in answering these questions. I would choose the easier ones first. What I do want to emphasize is that we are not teaching you to reflect in the y-axis. We're only teaching reflect in the x-axis. And because of that, you always will start with this formula, y equals square root of x. With this function, you're always starting on the left and going to the right, whether it's going up and to the right or down and to the right. You always start with the left point, okay? So when I look at this graph, I think the red points are the easiest ones to come up with a function. So if you look from the parent function, all that's happening is it's shifting to the left 2 units. So let's type in our parent function, y equals, and then to get the square root symbol, we have to do down there. All right, so this is your parent. Now, I'm dealing with the 2 red. So I'm going to click on that little button up there, and I'm going to change this to red. You don't have to, and if you didn't do it, it's not a big deal. I'm just, being particular. So if we are going to go to the left, horizontal shifts means that we're going to manipulate the radicand, so the number underneath the square root symbol, the radical symbol. And left and right goes the opposite sign of what you think. So you think, oh, I'm going to the left, that'll be taking things away, subtracting. Nope, it's actually addition. So when I do x plus 2 as the radicand, we get the graph that goes through the 2 red points. And that's the great thing about Desmos, though. You can play with it. You can say x plus 6. Oh, that doesn't work. X plus 2 does work. So it's okay to make a mistake because all you have to do is delete it and retype another number. All right, next, I think the 2 green dots would be the next easiest function to tackle. So y equals the square root of x, and it's already green. That's great. Oops, I don't know. There's an extra square root in there. Okay, so from the parent function, it goes over to the right 1, 2, 3, and up 2. So if it's going to go to the right 3, we would actually do the opposite of what you think. You're going to subtract 3 inside the radicand. And then to go up and down, we need to add and subtract numbers outside of the radicand, or the radical symbol. So in a vertical transformation follows the symbols that you would think. So adding 2 would go up 2, subtracting 2 would go down 2. So let's add 2. And now our green line goes through the 2 green points. The next ones I think would be easiest are the yellow ones, only because they're still from left to right, it's still going up. Whereas the blue and the purple ones from left to right, they go down and then down. So let's tackle the yellow. Left to right goes up. So let's type in y equals the square root of x. I'm going to change my color to yellow or orange, whatever you want to call that. Now, it definitely goes up 1 from the parent function. So on the outside of the radical symbol, I'm going to add 1. But I get through the first point, but I don't go through the second point. So if you look at this, and I realize that it's a lot going on here, maybe if I zoom in just for this. most of the time you would go up, well, the square root of 1 would be 1, so you'd go up 1 over 1. But I need to go over 1 up 2. So the point that's supposed to be right here is stretch vertically up 1 more unit. So instead of going to the right one up 1, we're going to go to the right one up 2. So to get from 1 to 2, we would multiply by 2, and that vertical stretch goes on the front end. So now you have your formula for the 2 yellow points. Okay. For the blue, I think blue is easiest to tackle between the blue and the purple. So I'm going to start with this point. So let's plug in y equals the square root of x. And let's make it blue. Okay, so from here, I have an original point that goes to the left 1, 2, 3, and goes up 2. So let's just get that in place. So to the left 3 means we're going to add 3, and then up 2 outside the radical, add 2. Okay, the problem is it's going up, and I needed to go down. So I'm going to put a subtraction symbol, negative, in front, and it flips in the x-axis, so it goes down. Perfect, so that went through the blue points. Now in the middle of all this mess, we have 2 purple points right here, and then it goes down here. So let's type in our parent function, y equals square root of x. And the original point, remember we start from the left point, is up 2 on the y-axis. So it goes up 2. So let's just get out of the radical symbol and add 2. Lovely. And let's change it to purple. Okay. Now, it is supposed to go, if it was just the parent function and it shifted up 2 vertically, then it would be up 1 over 1. Great. Now, if we were going to reflect in the x-axis, it would go over 1, down 1. But we don't go down 1. We go over 1, down 1, 2, 3. So this is reflecting in the x-axis, but also it's vertically stretching it by a factor of 3. So here I need negative 3 in front. And then you can see that it goes over 1, down 1, 2, 3. And if we zoom out to use that scale factor of 1, that's how your graphs would look. For number 18, you have your points. I'm zoomed in a little bit on this, but my scale factor is going by ones here. So if yours looks like this, I'm going to zoom in so I can see it a little bit better, but I don't want to have those half scale factors. So when I look at this, I think the easiest one that's going to be able to come up with an answer, a function, is blue. So we always start with the left point. Let's first type in our parent function. So we have y equals the square root of x. And I would like to make this blue. Okay, so the original point is going to be over to the right, 1, 2, 3, and up 1. So if I'm going to go to the right 3, we're going to subtract 3 in the radicand, and then up 1, we go out of the radical symbol and add 1. Okay, and that actually goes through both points. It's not vertically stretching or shrinking, and it's not reflecting in the x-axis. Next one, let's do instead, let's look at green. Well, green is a little bit goofy too. Let's look at red. So red goes over 1, 2, well, our original point goes over 1, up 3. So let's type that in. Y equals square root of x, and let's make it red. Okay. And if we're going to go over to the right 1, we're going to subtract 1. And if we're going to go up 3, we'll get out of the radical symbol and add 3. Okay, the way that I would look at this red graph, first of all, you can guess and check. Like, you know it's vertically stretching, because if this was the parent function right here, this red, Granted, the original point is not at the origin, but still this is the original parent function's shape. This point right here should be here, but it's way up. Therefore, it's vertically stretching. So we need to add a number in the front of the radical symbol. Because of that, you could play with it. You could say, hey, I'm going to stretch it by 3. And, oh, too much. I'm going to stretch it by 2. Oh, too little. So it's in between 2 and 3. So we can do 2.25. Nope, too much. 2.1. Oh, that would work. And if you want to get a little bit more creative, you can add another 1 behind it, and it goes even more accurate onto that symbol. But this is Desmos, so I'm not going to give you one like that on the test. This is just a challenge question to manipulate it and try to figure out your answers. So for purple, it's still going up. So let's do y equals the square root of x. And we start off by adding 1. Okay, great. Let's change the color to purple. All right, and if I look at this, this is the original parent function shape. This point is above it, so we are going to vertically stretch it. Now, I don't think you're going to stretch it by 2. I think it'll be less than that. Yep, because now the point's below it. So let's do 1 point. If you did 5, that's still too much of a stretch. So let's do 1.2. A little bit too much still. How about 1.1? Too little. 1.5. Perfect. Now it goes through. And like I said, you're just playing with Desmos on this problem. So don't worry that you're going to have one like this on your test. We'll be very exact, more like number 17. All right, here we go. Green, because it's still going up. Y equals the parent function, square root of x. We are going to start with this point to the left, 4 down 1. So to the left 4, we'll add 4 in the radicand and then subtract 1. Let's change the color to green. And that's lovely, except for we're too high here. For the second green point, it's going up. That's the original parent function shape. But I'm stretching too much, so therefore it's going to be a shrink. So let's do 1/2. Too small of a shrink. All right, let's do 3/4. 3/4. That's pretty close. I would maybe use a decimal now that I look at this, because if I do 0.75, that's 3/4. That's pretty close. If I do 0.8, that's too high above it. So if you really want to play with it, just add another decimal behind there. And they seem to be very close to 8. So how about 0.77? Oh, I like that one. Stress again, I will not do this too on the tests, but Desmos is a fun tool that you can manipulate, and that's why this is a challenge question. All right, last 2 points. They're going to be the yellow or orange graph. So parent function starts there. We're going to go to the left 1, down 1. So let's add 1 in the radicand and then subtract 1 outside of the radical symbol. If we put this negative symbol in front, it's going to open down, and oh, it happens to go through both points perfectly. So from here, if you go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's a perfect square, which is why we don't have to vertically stretch or shrink it, because the square root of 9 is 3. 1, 2, 3. All right, I hope that answers questions 17 and 18 on Desmos.